Okay, welcome to video 1.22, beginning at page 41 and ending at page 54. We're going to be learning about working with equations of partial linear relations. Now, from the previous video, we talked about the equation of a line that passes through the origin. Any line that passes through the origin is called a direct linear relation, origin being 0, 0. And we know that the equation for this particular line is y equals mx. Okay, and that was explained in the previous video. Now, what happens if we have a line on a graph that does not pass through the origin? It passes through anywhere but the origin along the y-axis. Let me just continue that down this way here. And let's say we've got a line that maybe goes this way here. There's the origin right there of 0, 0. And this line does not pass through the origin. Well, what is the equation for that line? Well, this particular type of line that does not pass through the origin is called a partial linear relation. We know that from previous videos. So what is the formula for that line? Well, the point where it crosses our y-axis, we know, is called the Y-intercept. So what we can write down, remember everything starts with the slope formula, we can write down y is equal to mx, but because this does not go through the origin, it passes somewhere along the y-axis, the y-intercept, right there, we write plus b, where this value of b is that point along the y-axis, which is the y-intercept. So if I wanted to write down an example of a line in this form of y equals mx plus b, for an example, for a line that maybe had a slope of, let's say, 3, and it had a y-intercept of, let's say, minus 3. How would I write this down in this form of the equation? Okay, this is called slope y-intercept form of a line. Well, the formula we know is y equals mx plus b. So all I need to do is substitute these values in here, and I can say that using these values of a slope of 3 and a y-intercept of negative 3, I can say that y is equal to 3x minus 3. Or if I had a slope of 3/2 and I had a y-intercept of 9, following this formula of y equals mx plus b, I can just write that as y is equal to 3/2 x plus 9. Well, now that I understand that I have an equation for a line that does not go through the origin, it is a partial linear relation, the question becomes, well, how do I graph something like that? Okay, so, well, let's do an example. Let's take this example of y equals 3x minus 3. We have a slope of 3 and we have a y-intercept of negative 3. So this is the formula that we're going to, or the equation that we're going to be working with. How do I graph something like this? Well, one of the easiest ways that we can graph it is we can make a table of values. We'll go back to our good old-fashioned table of values, like this. And I'll do it very similar to the example from the previous video. I will write the equation of the line up above here, which is y is equal to 3x minus 3. I'll put another line across here. Divide the whole thing like this. I'll put an x column and I'll put a y column. And then I have to put in values. All right, well, why don't we start with, well, I don't know, we can do anything we want. Let's start with 1 for x. We're going to give some x values here, and then we're going to calculate y. Let's go 1. Let's go 0. Let's go negative 1. Let's go negative 2. -3, and -4. Okay, so those are the x values that I'm chosen. Okay, and now what we want to do is we want to calculate the y values using this formula here and substituting the values in for x and solving for y. So when x is 1, I just substitute 1 in there, so 3 times 1 is 3. Subtract 3, 3 subtract 3 is 0. When x is 0, so 3 times 0 is 0. 0 subtract 3 is -3. Y is -3. And when x is 0, y is -3. That corresponds to my y-axis and my y-intercept of being -3. All right, when x is -1, y is what? Well, let's substitute -1 in here. 3 times -1 is -3. Subtract 3 is -6. When x is -2, 3 times -2 is -6. Subtract 3 is -9. -3 in here. 3 times -3 is -9. Subtract 3 is -12. And -4 times 3 is -12. Subtract 3 is -15. Now let's go back to our check here. If I want to know if it's a straight line, just to prove that it's a straight line, I have to have a constant rate of change between each of these x values and a constant rate of change between each of these y values to prove that it's a straight line. So the difference between 1 and 0 is -1. 0 and -1 is -1. -1, -2 is -1. -2, -3 is also -1. And -3, -4 is -1. So we have a constant rate of change of -1. And our y values from 0 to -3 is -3. From -3 to -6 is -3. -6 to 9, -3. 9 to -9, -12 is -3, and -12 to -15 is -3. So I have a constant rate of change, so that just proves that it's going to be a straight line. So how do we graph something like this? Well, I'm working with negative numbers here now. So when I'm working with negative numbers, I have to draw a graph like this now. Okay, and have 4 quadrants. I can label this y, I can label this x, and now I have to give it a scale. Now I know that my x line is going from 1 down to -4, so I know that I've got 1 here. I could do 2, 3, and 4, just for labeling's sake, but I'm going down here to -4, so I'll say that's -1, -2, -3, and -4. And my y values are going from 0, the origin, down to -15. Okay, so I might go by 5s this time. So I'll say that's +5, that's 10, that's 15. And here is -5, -10, and -15. Okay, so now all I want to do is I want to plot these coordinates here. So when x is 1, y is 0. So when x is 1, y is 0. So it's going to be x is 1, y is 0, right there. When x is 0, y is -3. So it's about right there. So right off, by looking at this, I know that this is going to be my y-intercept. In my y equals mx+ b formula, this b right here needs to be -3. Okay, and it is. When I graph it, it's -3. X is -1, y is -6. So I go x is -1, y is -6, which is about right there. X is -2, y is -9. About right there. X is -3, y is -12. About right there. And x is -4, and y is -15. Right there. And I can just connect all those points with a straight line. Put arrows at each end of the line. And there is the line drawn on the graph of the equation y equals 3x minus 3. Straight line, because we know we've got a constant rate of change between our x and our y values. Y-intercept of negative 3. You can see it crosses the y-axis at negative 3. And so this is how you would draw the graph of a partial linear relation using the formula y equals mx plus b. Okay, so go through the examples from pages 41 to page 54. You're going to have examples of different kinds involving direct and partial linear relations, a line going through the origin and a line that doesn't go through the origin. They're going to be practical examples, okay, of real life situations. Look at how the equations are used. Look at how they're graphed on the examples, and then work on those graphing questions up to page 54.